So, hi friends, today we are going to discuss about prototype and registry pattern. So first we will go with prototype pattern. So as usual we will go first with the intent of why we are going with this prototype design pattern and later then we will move on to the code base. So why this prototype design pattern, why do we need this prototype design pattern? So this prototype design pattern is basically to create the prototypes. For example, if you want let us say if you want to build an aeroplane, so first thing is you will not directly build the aeroplane, right? You will first basically create a prototype, first understand the design, and then you will create a further actual interface. In a similar way, for example, imagine in a childhood days, somebody in your childhood days, if somebody has done their homework and the other people will also copy the same homework, only thing is the roll numbers will be different. So the first person who has so the first person who has done the homework will be having the roll number 1, and obviously whoever copies the homework will need to change their roll number. So fundamentally what we are trying to say is the first person who did the homework is basically the main prototype, and we are trying to clone those clone that particular prototype from where it has come. And so why this is useful, why this prototyping is useful, why do we need to create a clone of these original copies? So there are a lot of places where we need to uh, have this usages. For example, if you want to create a user for testing applications like JMeter, consumer facing applications, for example, if you want to create 1 million users, you will not basically go on creating every time you will add first name, last name, email ID, phone number. You cannot keep on adding the 1 million users one by one, right? If you want to do the create users 1 million users manually, basically you will be creating users one by one if it's a normal way. But for testing purpose, you don't need to. If you want bulk of users, then obviously the prototype design pattern will be useful, because you will create one master, and from that master you will create several copies and you will make use of it to create a bulk users. So that is one more usage, or one more usage where we create. And if you see the random API in the web, basically they'll call the API, create the user, and if you see the user, when we call that particular API, the user changes for every for every request. So basically this is called the random API. The ID and also you'll be you'll need to limit the for rate limiting uh, and imagine if you want so imagine if there is a scenario where you want to call the API to create the user, and the API which you are calling has some limitation is called rate limiting. So they have restricted 100 requests per day to create the users. So in such case, you cannot create, for example, if you want to create something like some 10,000 users or 20,000 users, so obviously it will not be possible, right? So call the API whichever times, call the API once and copy the values whenever there are thousands of objects. So that is the main thing. So first you call that API and create the copies from them. So you cannot simply keep on creating, you cannot simply keep on calling the APIs 10,000 number of times, 20,000 times, because when there is a rate limiting, basically they are limiting your requests. Okay, so that is one thing. So first thing is you'll just call the API once, and remaining times you'll just copy the values. Okay, so that's the one thing. And coming to game development, for example, if you see something like Call of Duty or PUBG, something like that, basically if you see, there will be maps, they will be having different houses in the map, and stairs you'll be having mountains, you'll be having different objects within the game development. So when they are creating these objects in the game development, obviously they'll create a object which is basically the master copy, and from that master copy they'll try to clone the objects. For example, imagine if you are having a gun in your PUBG game, the bullets obviously are similar, right? For example, one bullet will be of one type. There will not be such scenario that there will be one bullet of one type and another bullet of other type. All the bullets will be the same thing, right? The only thing is how much, the only limit will be for one round how many number of bullets will be there, and what is the firing rate, basically what is the firing rate, and what is the power of the gun. So that is what it matters, but bullets obviously will be the same. So he will create one master and it will create copy from those things. Similarly, for example, if there are two houses in the game, for example, if there are stairs for the house, for the second house he will not create stairs one more time, he will basically copy the same stairs and he will use it for the second house. So this is kind of like cloning the objects. You're basically cloning the objects. It's not like copy pasting, it's kind of like you want to clone the objects. So there are some objects and you wanted to clone it. And machine learning, using the same models while training the models, basically the machine learning also they will be using these scenarios, right? While training the models, if you want to iterate over those models or repetitively over the period of time, so then you can go with this such things. And user defined times, so it's shallow copy. So this is basically a shallow copy, deep copy. So we have a separate video, let's do a separate video for this. So the reason why we are discussing a shallow copy and deep copy is basically to whenever there is a cloning happens, there are two types. There could be a shallow cloning or there could be a deep cloning. So and also whenever they are creating a new string in basically in Java or in any object oriented languages, it will create a new object instead of modifying the old object. The main reason here is to basically to compare the state of the object, to compare the state. For example, if you are changing from one value to other value, creating a new object will be much more easier for the system to compare in contrast to modifying the existing object and completely checking it whenever the values are being changed and who changed it. So that is the main reasons. Even if there is a memory footprint increases, but overall efficiency will be the overall time complexity or the efficiency of retrieving the objects and checking the diff checking of different objects and different states will be much more easier. So that's a different concept. Okay, so coming to steps of creating a clonable cloning, prototype design pattern. So first thing is create a clonable interface and create a concrete class, and implement that. You will be implementing that obj clonable which we have created earlier, and we will implement that clone method. So when you are creating a prototype, it could be a model, sample, or a blueprint. Clone the prototype as required. So clonable tree, so that's the one. Okay, so let's check the code for more details. Okay.